Welcome back, my friends, to the show that never ends. I'm so glad you could attend. Come inside, come inside. I turned myself around. I didn't want you to get bored looking at the whiteboard. You can see the back of the room now. Here, look. There's the windows. There's the rest of the lab. All right. Here I am. This is the second 50 review slides. This time we're going from names to formulas. Names to formulas, ionic and molecular. So here I'm going to give you names. You got to write the formula. This should be quicker for you. Have your reference table out. Periodic table, have that open and get table E ready because we're going to give you names. You got to do the formulas. Now, you also have to decide, is it ionic or molecular? Quickly, the rule is if your first name is in metal or the first part of your formula is in metal, you are ionic. If your first name is a non-metal, right? There are 22 nonmetals. 6 of them are noble gases, they're out. So if there's 16 atoms as your first name, you're molecular. The only exception is ammonium. Ammonium is NH4 positive 1. It's a cation, but it starts with an N. That's the only exception you got to worry about. Here we go. Get a piece of paper, 1 to 50. Okay, you should be able to get through these whole things. Probably take you about 20 minutes if you zip, right? But you got to correct it in red. Checks for good, X's are bad. The more checks you get, the happier you are. The more X's, that means you got to study more. Don't think you're going to get 100. I make mistakes. I had a mistake in the last slideshow. I had to fix it. Mistakes can happen. You learn from them. You push against them. You say, I'm not going to do that again, right? Here we go. You got to have paper. I'll stop again. See what it says in the bottom? You can't do this without paper. If you don't have a piece of paper and a pen and your reference table, everything else, get it out of the way. Tell your brother to get out of the room. No dogs, no music, no food, no cheese doodles ever. They're bad for you. Get something, paper, pen, reference table. Here we go. Here's the name. Here I'm giving you names. You got to write the formulas. And is it ionic or is it molecular? Magnesium's a metal. It's ionic. Magnesium's a positive 2, oxygen's a negative 2, MgO. This was easy. They're all easy. 49 to go. Tantalum fluoride, tantalum. Tantalum's a metal. Number 74, makes positive 5 ion. So when you crisscross that with fluorine, which is a negative 1, TAF5, of course it's ionic because it's a metal. Strontium chloride, strontium is a metal. Number 38, strontium makes a positive 2 ion. So write that, Sr plus 2, Cl negative 1, crisscross. If you need to hit pause. Don't let me go too fast. Make sure you get what you need. But this is not hard. We could do it this fast. I'm doing it without the reference table. I mean, I'm good at this. You're learning this. Hit pause. Look, there's the bell. Take a break. I'll open my seltzer. Strontium plus 2, chlorine negative 1. It's ionic. SrCl2. Nickel Roman numeral tribromide. Put your finger in the box. Nickel's number 28. Nickel makes 2 kinds of ions. This one is the positive 3. That's why it's Roman numeral 3. So right, Ni plus 3. Bromine, Br negative 1. Crisscross. It's an ionic compound, and it's NiBr3. You're getting this. Carbon tetrahydride. Carbon is C. C for cookie, C for Charlie, C for carbon, C for cuckoo, cuckoo for Cocoa Puffs. Carbon, tetra, 4 H's, CH4. Of course it's molecular. Carbon's not a metal. CH4, we also call this what? Methane. Methane's the organic name, right? That's the Mr. Arbuso name. And carbon tetrahydride, that's the honey bunny name. Titanium, Roman numeral 4 oxide. So you have to write this. This one's tricky, right? This one's tricky. Ti plus 4, O negative 2. When you crisscross, you're going to get that in a 2 to 4 ratio. I don't know which way my hands are supposed to show, but it's a 2 to 4. What does John Dalton say about 2 to 4? Simple whole number ratios. TiO2, right? There's some information there in red to remind you. It's ionic, of course, because titanium is a metal. Nitrogen dioxide. Nitrogen's a non-metal. Nitrogen's going to make a molecular compound with 2 oxygens, NO2. This was easy. 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 Titanium, Roman numeral 3. Put your finger in the box. Titanium is number 22. Roman numeral 3 means positive 3. Write that down. Ti plus 3, O negative 2. Crisscross. Ti2O3. Titanium, Roman numeral 3 is the cation. Oh, snap, another titanium. Stick your finger in the box. Titanium also makes a positive 2 ion. So write it. Ti plus 2, O negative 2, crisscross. 2 to 2. What does John Dalton say? 1 to 1. T-I-O. Tio. That means uncle in Spanish. I don't speak Spanish, but I like crossword puzzles. And I also know Titi means aunt, although that's probably not correct. We used to call a good friend of ours Titi Mimi and Tio Louie. All right, aluminum nitride. Aluminum's a metal. Aluminum follows that simple isoelectric to a noble gas rule. Becomes a positive 3 cation. So write that. Al plus 3. Write it down. Don't do this in your head. Nitrogen. Simple isoelectric monoatomic anion becomes a negative 3. Positive 3, negative 3. 1 to 1. Aln. It's, of course, ionic. Aluminum's a metal. Everybody knows that. They make airplanes out of it. Can't have a non-metal airplane, right? It could be a little plastic one, but it can't take people anywhere. Got to be aluminum. Phosphorus trichloride. Phosphorus got a lot of letters, right? Luckily, the symbol is just P. P, it's a non-metal. Three chlorines. PCl3. Molecular. That was easy. It's not easy. You're getting smarter. I can see it in your eyes. Look at my eyes. I don't know which way the glare is. Look at my eyes. We're doing okay. Boron rhymes with one of my favorites, right? Number 5. Boron with 3 fluorines, BF3. Of course, it's molecular because boron is a non-metal, and boron rhymes with, say it, and don't say it about me, because that's not me. Don't be talking about me like that, even though I can't hear you. Carbon is a non-metal, capital C for Charlie and Cookie and carbon. Carbon with tetra, 4 fluorines, CF4, and of course it's molecular because carbon's not a metal. Carbon's a non-metal. Dinitrogen trioxide, there's a lot of prefixes here, right? 2 nitrogens in the front, 3 oxygens in the back. It's a molecular compound because there's no metals. N2O3, that was easy. Oxygen difluoride, oxygen's a non-metal, makes it molecular. O for oxygen, difluorine, OF2. You can write it OFF for off, but that's not correct, but it is cute. Dumb chemistry joke. Hard to make chemistry jokes about formulas. Not too many formulas even come up too cute. Sulfur trioxide. Sulfur is a molecular compound now because sulfur is a non-metal. Sulfur trioxide is molecular. SO3. Trioxide. Trioxide. That looks like trioxide. It's trioxide. Silicon dioxide. Silicon, Si, number 14, is a non-metal. That means silicon dioxide with 2 oxygens will be SiO2. Beach sand. Try to remember that. That's cool. You can go, next time you go to the ocean, you can say, yo, the silicon dioxide is way too hot for my feet, right? Your friends will not be impressed. I will be impressed, but I won't be there. You can think about me. Think about me when you're on the beach. Silicon tetrafluoride. Silicon's still a non-metal. It's still a molecular compound here. Silicon with 4 fluorines. SiF4. Are you guys getting better at this yet? I feel like I'm going faster and faster. I'm like on a roller coaster. I didn't even have a lot of coffee today and I'm really zooming. I'm zooming on Zoom. It's like a loop. It's almost like that movie with Matthew McConaughey or what's his name? I don't even know what it's called. Inception, when everything starts folding on itself. I'm zooming on Zoom. Oh my goodness. Dihydrogen monosulfide. Dihydrogen. Hydrogen's a non-metal. 2 hydrogens with 1 S. H2S. Stinky gas. Arsenic. Arsenic's a non-metal. It's number 33. Arsenic, AS. And then 5 bromines. AsBr5. Arsenic pentabromide. Oop, going too fast. Selenium trioxide. Selenium is number 34. Se. Se with 3 oxygens. SeO. Green giant. No, that's a commercial. I get carried away. Selenium O3. And it's ho green giant. The best vegetables in the world if you're going to eat frozen vegetables. Green giant. Phosphorus triiodide. I like that with the two I's, right? Phosphorus, a lot of letters, change it to P with 3 iodines. PIII or PI3, not III. This is, remember this one? This is pie. Eat this and say pie. I like cherry pie. I like apple pie. I like phosphorus triiodide pie. Don't eat this stuff. Fluorine monochloride. F is a nonmetal. F with 1 chlorine. FCl. FCl. Hydrogen monobromide. Hydrogen's a nonmetal. 1 bromine. H with the Br. HBr. No spaces. Keep them snug. They're bonded together. They're really tight. Oh, I like this one with the X. Anything with the X is really cool. Sulfur hexabromide. 1 sulfur and 6 bromines. S Br6. Just like I said, 6 bromines. Of course, it's molecular. Neither of them are metals. Phosphorus pentachloride. Phosphorus is still a nonmetal. Still got too many letters. Capital P and then 5 Cl's. Cl5. PCl5. Say this. Say it out loud. Take a break. PCl5. Say it like you mean it, like you know what you're talking about. The more you say stuff like this, the more it'll be comfortable. It's very weird to say this, PCl5. Normal people don't talk like that. You got to learn to be less normal. You got to learn to be more chemical. You got to be more like me. PCl5. Phosphorus pentachloride. V. V for victory. V is number what? 23. Vanadium Roman numeral trioxide. So you got to write V plus 3. O negative 2. Do the crisscross deal. It's ionic because vanadium's a metal, even though you don't know vanadium. Vanadium is a good friend of mine. She lives on 23rd Street. I mean, she's element number 23. Vanadium, Roman numeral trioxide, V2O3. If it's got a Roman numeral, that's the ion charge that it is. Chromium, Roman numeral 3, number 24. Chromium, Cr plus 3. Sulfate's the tricky one, right? Sulfate's on table E, SO4 negative 2. Let's see. Isn't that weird? I screwed this slide up too. The SO4 is still a negative 2 ion. Now we're good. You see what happens? You can make mistakes. I can make mistakes. I don't care. Don't worry about mistakes. Make mistakes. When you make a mistake, you laugh at yourself. You'll say, damn, can't be doing such dumb stuff. I got to not do that again. I want to straighten this out and do it right. Who cares I made a mistake? I'm a professional teacher. I teach chemistry and I screwed up something very basic. You know why? I don't know, because it's a dumb mistake. And I don't care. I don't care. Even if the principal was watching, I'd say, you know what? Who cares? I made a mistake. Leave me alone. You make mistakes. Make some mistakes. Write them down. Make mistakes and then X them. X's make you feel good. Like, damn, I'm not gonna do that again. Right? Here we go. Arsenic triiodide. Arsenic, AS for arsenic. It's element 33. 3 iodines. ASIII. No. Who said that? I. That was from Finding Nemo, those dumb birds. They were doing the arsenic triiodide song. Those birds were annoying. Hey, Peach. I used to like that show. I really like Finding Nemo. Just keep swimming. Here we go. Arsenic triiodide was molecular because they're nonmetals. Tantalum. Ooh, I like that one. Tantalum, excellent element, 73. Tantalum is a metal. Better put your finger in the box. I can see from here, though, it's a positive 5, and there's no Roman numeral. You know why? Because it only makes one kind of cation. Don't need a Roman numeral. Ta, and then in parentheses, you need 5 hydroxides. The hydroxide's a -1 polyatomic anion. See how I'm saying stuff and you start to understand me the way I'm talking now? Hydroxide is a -1 polyatomic anion. Tantalum is a +5 metallic cation. And when you crisscross it, you need 5 hydroxides. You only need 1 tantalum, and no registered nurses are needed, no Roman numerals. Iridium, Roman numeral 3 chloride. Iridium is element what? 77. IR. It's got a +3 charge. How do I know that? Because it's Roman numeral 3. I don't even have to look. If it says Roman numeral 3, it's a +3. Chloride's a -1 because I'm starting to remember that one because I'm doing so many. I hope you're remembering that too. Crisscross, +3 and -1. You're going to need bada bing, bada boom, IRCl3 and The iridium gets only 1 because chloride's a -1, and you need 3 chlorines to balance that. Carbon diselenide. Carbon, capital C. There's only 1, so it's C. Selenium, which is selenide. Selenium is element 34, Se, so it's going to be C, selenium 2. C, Se2. Iridium's back, 77. Iridium this time makes +4 ion, and phosphate on table E is in -3. Let's see if I got this right. Yeah, I did. I got it right. See, I feel good about myself. When you get things right, you feel good. When you get things wrong, you say, "Oh, I'm a dumbhead," and you fix it. And you're not that anymore. You're not dumb in a bad way. You know what I mean? It's a bad word to say. Maybe a professional teacher should never say dumbhead. I mean, you know, you make a dopey mistake. I make dopey mistakes all the time. IR3, and then in parentheses, you got to have 4 phosphates. You need 3 iridiums and 4 phosphates. Zinc oxide, put your finger in box 30. Zinc makes a +2 ion. Oxygen makes a -1. Zinc only makes 1 cation. Even though it's transitional, it's only going to make 1 kind of cation. So this ionic compound is just ZNO. No Roman numeral needed because it only makes a +2 ion. Copper, Roman numeral 2 oxide. I'm not going to look in the box. Element 29 is copper. Copper here has got a +2 ion. I remember oxygen by now, right? I hope you do too. Oxygen's -2. +2, -2 crisscrosses to 1 to 1. It's an ionic compound, and the formula is CuO. See you later. No, not yet. We're going to leave soon. Copper, Roman numeral 1 oxide. Copper here has got a +1 charge. Oxygen's always a -2. When you crisscross, you're going to need Cu2O to make it balance. 2 positive 1s and 1 -2 sums to 0. All ionic compounds are net neutral. The positives equal the negatives. They're neutral. They made a positive cations and negative anions, but together they combine in a proper ratio to get back to neutral. Copper again with the +2 ion. Sulfur's element 16. Copper's a +2. Sulfur's a -2. Copper's a metal, so this is an ionic compound with this easy formula, CuS. CuS. Zirconium, element 40, right? Zr. Put your finger in the box. Zirconium makes a +4 ion. This one's tricky. +4, -2. Crisscross. That gives you a 2 to 4 ratio. Woo! What's Sean Dalton say about 2 to 4? Change it. 1 to 2, or I don't know which way I'm looking in the computer here. It's going to be 1 zirconium to 2 sulfides, and it's ionic. Zirconium S2, ZrS2, 1 zirconium, +4, 2 -2s, balance. And even though it's transitional, it only makes a +4 ion. Zinc sulfide, we did this zinc already, number 30, only makes a +2. Sulfur, also when it makes an anion, is a -2. +2, -2 crisscrosses to 1 to 1. And of course, ZNS, no Roman numeral needed. Calcium hydroxide, Charlie Arbuso. Ca, number 20, makes a +2 ion. Hydroxide is one of my favorite polyatomics. It's a -1. So when you crisscross, you're going to need 1 calcium and 2 hydroxides. That means you need parentheses this time. Ca double hydroxide. CaOH twice. Right? CaOH, OH. But not O2H2. That's CaOH and another OH. CaOH twice. Magnesium nitride. Magnesium is element number 12. Nitrogen's element number 7. We got a +2 and a -3. Crisscross. And it's ionic because magnesium's a metal. Mg3N2. These are getting easy. Do you feel it? You're starting to feel like, hey, I'm finally getting this, all right? We're going to do one more slideshow after this. I hope you're going to do it. And that's called the master set. And when you do that, you become a master. You start to own this stuff like a dog on a leash. You got to put your dog on a leash and take him for a walk. Otherwise, he's going to be busy in your kitchen. Can't have that. Strontium fluoride. Strontium's element number 38. Sr. It's a metal. +2 ion. Fluorine's a -1 because it's in group 17. Follows that simple isoelectric rule. I have 7 outermost electrons. I need to get to 8. That makes me a -1. SRF2. Of course, it's ionic. The blue stuff tells you what you're thinking. If you make a boo-boo, X it out and read it. Think about it. Call me on the phone. Say, yo, Charlie Abuso, what's up with this? Maybe it's a dumb mistake because I'm a dumbhead sometimes. Maybe I got to fix it, right? All right, here we go. rubidium phosphide. Now watch, this is not phosphate. Phosphate's on table E. This is phosphide. Rubidium's element what? 37, positive 1 ion. Phosphide is phosphorus with a -3. Crisscross, you're going to have 3 rubidiums for every phosphorus in a 3-to-1 ratio. Simple whole numbers, can't be reduced. It's ionic, Rb3P. Here we go, rubidium phosphate. Now phosphide and phosphate both have phosphorus, but they're not the same. Phosphide is phosphorus anion. This is PO4 with a -3, crisscross, right? So we're going to need 3 rubidiums and 1 phosphate. No parentheses needed here because we only have 1 phosphate. If we had a multiple of phosphates, then we need parentheses, but we don't have that here. We have 1. Ammonium phosphate. Oh, snap. Polyatomic power here. We got a polyatomic cation, polyatomic anion. Write them down. NH4 is a +1, and phosphate, PO4 is a -3. +1, -3 means you got a crisscross. You need 3 ammoniums. Say that to yourself. I need 3 ammoniums. How am I going to freaking write that? That's complicated. And I'm going to need 1 phosphate. That's pretty easy. This is how you do 3 ammoniums. You put it in parentheses and you triple it. NH4 in parentheses 3, PO4. Now again, ammonium is a weird exception. It's not metallic, but it is a cation. That's our only exception for what goes in the front. Ammonium iodide, going to be an ionic compound again because ammonium is always a cation. Ammonium is a +1. Iodine, as it turns out in group 17, makes a -1. Ionic compound, and it's going to be NH4I for ammonium iodide. No spaces. Keep them tight. This is an ionic bond. This is tight, like love. They are bonded together, no spacing. Silver nitrate. Silver is element 47. You knew that. You remember that. You knew that. You know that. Oh, somebody texted me. They want help for this one. Silver's 47 makes a +1. Nitrate's NO3 -1. NO3 is on the table E. Don't mix it up with nitrite. This is nitrate. AgNO3, +1, -1 in a 1-to-1 ratio. We don't need a Roman numeral. Silver's transitional, but it only makes 1 ion, so there's no Roman numeral needed. Silver nitrite, you see this one? This is the other one. Nitrite is not nitrate. It's almost, but it's a 1 oxygen different. It's a different name. It's a different formula, different compound, different properties. Don't mix them up. They're not the same, right? It's ionic, and this time it's AgNO2 because nitrite is NO2. Nitrate is different. Nitrate is NO3. Bismuth, Roman numeral 5. Now, bismuth happens to make 2 different ions. Bismuth is what? Element 83. This one, not even going to look, right? Bismuth +5. That's what the Roman numeral means. It's telling you which ion? The +5. Nitrite. We just did this now on table E. NO2 is a -1 ion. So if you got a +5 and a -1, you crisscross, you're going to need 1 bismuth, and you're going to need 5 nitrites, which means you need parentheses. BiNO2 5 times. That's a pretty big thing. Bismuth nitrite. Okay? No Roman numeral needed in the formula. Roman numeral in the name. Never put a Roman numeral in a formula. Never. Oh, here we go. Bismuth, Roman numeral 5 nitrate. Again, very similar. Don't be fooled here. +5, but now it's NO3 -1. So it's almost the same thing, but it's BiNO3 5 times. Nitrate, bismuth, Roman numeral 5, nitrate. I was going to say I'm getting tired, and here we are. We're at the end again. Listen, you are getting better at this. I am going fast. You can go back, or you can do the slides without me, right? I'm going really fast because I'm excited. Still haven't had any coffee. I'm going to leave for coffee soon, and then I'm going to come back and go crazy. Listen, practice, practice, practice. This is not easy. These are a lot of funny names. Sometimes there's Roman numerals, sometimes there's not. You can't remember anything. Put your finger in the dang box. Don't think. Use your finger. Your finger will tell you what's right or wrong. Don't guess. That's even worse. Don't guess. Put your finger in the box. Everything is on, it's on the periodic table. It's on table E. And then the names, they're going to be on table S. And then you wrote a couple things down here and there. You wrote the naming rules down, the simple ionic naming rules, the transitional Roman numeral naming rules, the polyatomic naming rules, and of course the molecular compound prefix naming rules. Try not to mix it up. Try to put your finger on something that tells you what to do, because it's all really easy. And you got to be good at this. This is like learning how to talk chemistry. Soon, I'm just going to say stuff like zinc sulfide, and you're going to have to write it down. You're going to have to know how to talk chemistry. You're going to have to figure it out quick. You got to know where is zinc. If you can't do it, you know how, but you got to know where is zinc. Play with your periodic tables. Read them. Look through them. Read them. Say the names. And you get one wrong, you look it up. See if you can get through the first 50 atoms, right? You don't have to memorize them. Just get through them. Do it a couple of times today, a couple of times tomorrow. The more effort you put in, 5 minutes here, 5 minutes tomorrow, 5 minutes the next day, you'll have 48 of them down pat. And then 2 of them you'll annoy yourself with, and you'll have to look them up. But you're only looking for 2 then. You're not looking for 45 of them. You become much quicker and much more confident. The more confident you have, the better you are. The better you are, the happier you are. The happier you are, the better house you get, and the bigger spouse, and the nicer dog. You want a good life. You want a good life, you got to learn chemistry. I know chemistry, and I'm happy. There you go. Thanks for visiting. Peace and love.